Hi guys, my name is Nathan Metzger. I'm a graduate student here in the School of Mechanical Engineering working in the Energy Storage Lab, specifically on the fuel cell project. So I thought I'd just give you a brief kind of tour and a little bit of overview of the project that I'm working on. So what we have set up here is called a membrane electrode assembly. It's basically just an electrode for a fuel cell. So to start off, we kind of just stack these components on top of each other, like you see there. And then we'll come over here. And at the end of the lab, we have our hot press that we ordered in. So this is still heating up. Typically, we try to get it to 275 degrees on the upper and the bottom plate. That way you get an even heat throughout. And then we'll close it in here at about roughly 50 psi for a minute or so. And that kind of fuses everything together in the electrode and then the cathode and the anode. So then once we do that, we take this over here to our fuel cell setup. It's a little bit messy right now. We've got a bunch of different tubes going on because we run so many different tests. But basically what you have here is a cathode up on the top in blue and an anode on the bottom in red. And if you look closely, that little white kind of membrane in there is what you saw on the electrode over there. So we stick that between those two graphite plates, and then we basically supply air to the cathode and then fuel to the anode below. And then a reaction occurs and it transfers hydrogen ions through the middle of the membrane, and that's what produces electricity and power. And we collect that current here and measure it. So one of the big problems with fuel cells is that methanol doesn't react in the anode, and it crosses through the membrane that you can kind of see over there without reacting, and that crossover causes an unstable voltage. And that's kind of been identified as like a leading barrier to entry in the market, and that's what my research has really been focused on trying to improve.